This is a technical understanding of QoS, quality of service across networks such as IP, MPLS, and benefits of SD-WAN networks. Brought to you by TMCnet and part of an enterprise sales upmarket, upmargin acceleration program. Available at your location, anywhere, anytime. Get certified Sales Smart. Designed to reduce the sales cycle, maximizing ROI, increase competitive edge, reduce staff turmoil and turnover, produces higher margins, provides improved sales leadership designed for small, medium, major channel and enterprise markets, and addresses UC, collaboration, SD-WAN, and different technologies. The focus of this presentation is to kind of cut to the chase and why we're moving to SD-WANs. Basically, presently we've got a router-centric model. Basically, the fast answer to why SD-WANs are gaining momentum is simplicity. Instead of complex to deploy, configure, upgrade, scale, and more. Basically, we're looking at simple, fewer parts, more simplicity in the management system, and lower costs. As you can see, managing an MPLS network is very complex with all the different routers, switches, labels, and other things to deploy. Basically, we're moving to a bandwidth-centric model where SD-WANs offer air traffic-like software-defined control, rely upon fast, cheap bandwidth, and simple switches to provide for scalable networks at a lower cost to deploy, scale, and manage. The challenge in migration is to rip and replace all the devices, migrate all the bandwidth to Ethernet, redesign management, and hope that this all will scale as easily and as well as your current network. But let's step back for a second and look at the SNA model, Systems Network Architecture, which basically sets the stage for all of this. When you look at how the networks were built, basically based on an OSI model, we look at the different configurations, applications, etc. But the complexity of applications has increased at layer 7. Layer 6 is presentation, layer 5 session, flow control, layer 4 transport layer, transmission control, layer 3 network or basically path control, routing, layer 2 data link where we have Ethernet and other kind of data link layers, and layer 1 physical layer where we've got optical fiber. As we can seen, the speed of bandwidth has gone from megabits to gigabits and tens of gigabits per second together in a very complex way, in the sense is that we have all different kinds of applications we need to support out there, and one can easily understand that the applications are not getting less complex, they're getting more complex and requiring more and more bandwidth out. So let's look at the Ethernet frame, which is really designed not for high-speed data network. It's designed for print sharing, but the idea that it was fast and cheap and basically has been used in your PC, Wi-Fi, and other technologies to provide for high-speed bandwidth. As you can see, it is not really scalable, but designed to be really usable. IPv4 is the layer 3 protocol, which you see in TCP/IP, and TCP/IP really doesn't really have a lot of quality control in it. And the idea is that what we're thinking about in bandwidth-centric models is basically let the bandwidth figure it all out and worry about data drops later. If people slow down, they slow down. We're not going to worry so much about technologies out there. Saying that, though, is that different diffserv, there are ways to make QoS really viable in many kinds of networks. The first was basically using the IP packet with diffserv and TOS, but no one really did that very much, even though it was kind of built. What became prevalent out there is MPLS, multi-protocol label switching, and the labels weren't really, really designed for specific applications, but the idea was that you could set your routers for voice, video, and other applications as long as they were supported across your network. The routers at the other end knew what they were about, and as you cross different kinds of networks, the labels were swapped or popped to different labels across different other networks to make sure that the bandwidth was supported out there. Together as a kind of a shim or an add-on to IP, and the idea is that it really helps provide a higher level of quality service and more professional layer grade and provide for network management, etc. But basically, unlike other IP networks who recognize TOS or MPLS, they route as is, and sometimes called best efforts with hot potato routing to get the packet off their network as fast as they can. So often different kind of networks really don't want your packets on their network. They want to get them off as fast. And so really there's no real financial incentive for networks to keep those packets on, etc. MPLS-enabled routers use labels to determine the quality of service for each route. Crossing multiple carriers, the label priority is swapped to the next carrier, such as voice, video, email, etc., shared, ensuring priority across to the edge of the network where the label is removed. So there wasn't really any kind of MPLS that really extended down to the desktop, and so that was another issue, that when you moved out off the edge, you were really still dealing with other kinds of fundamental issues out there. I think it becomes more complex as you on the edge, or buildings and homes and other kind of things. But there were many advantages. There are many advantages to MPLS, as you've seen here: new traffic control, hop control, automatic traffic control, traffic shaping, mission control applications, tunnel control, layer 1 support for interior and exterior BGP, border gateway protocols. And I think you kind of see how this kind of thing is that MPLS is not something that's really going to go away. It's just going to kind of be morphed into something that we use along with our SD-WAN networks. There are many other advantages for MPLS, as you can kind of see here. This is more a part of a more technical presentation if you'd like to see that, but we kind of think point. Again, there's still no quality of service built in, then different approaches are given. So we want to look at how these things all work together. I'm not going to go through each one of these. You can read them as faster than I can speak. And so it's really become some really more important that, yes, this all works together. It can work together, and quality of service is really key to this whole element out there of managing a network. The TCP at layer 4 provides some layer of error checking, but not really a lot of quality of service, other than the fact that did you get the bits, or did you get the packet or not? If not, resend the packet. That works very well for maybe email, etc. But when you look at video on demand, voice, etc., it really becomes very cumbersome and not. We look at IPv6. I think there's going to be some things out there, but again, IPv6 hasn't really been deployed as fast as people would have thought. There's RTP, RTCP, different kind of protocols that exist out there for voice, and I think those kind of have a role in how this thing fits together. However, it doesn't necessarily mean that there's going to be service down to the lower layers. I think when you look at what I put together here is what I call the Hollywood Squares approach to this, in the sense is that you have to look at issues more than just bandwidth out there, the type of applications that you need out there, what you're going to use them for, how fast is it going to grow, does it scale, is it part of a streaming effort, etc. So I think the whole challenge to providing QoS to this whole process is that I think that MPLS still is a viable player out there of an SD-WAN world out there. I think we kind of see how these things work together, and I think that's the real process. So meanwhile, back at the basics of SD-WAN, I think we need to kind of step back for a second. And in the beginning, local networks or local LANs were connected at your office devices. Sometimes they're called endpoints together via switches to connect your local computer service where your office applications were processed and stored. Then wide area networks or WANs connected your office via routers to data centers, clouds, where your website may be hosted and connected to the internet, such as called the interconnection of networks. Networks grew as more and more routers and switches were required to make all the connections to different data centers, your home, offices, and as we call it, smartphones, where you want to connect everywhere. As networks grew so complex, they were harder and harder to manage with all the different routers and switches. The benefits of SD-WAN fits in here, as certainly when you think of all the, we'll call it, handheld devices that we use out there. Let's look at how this works together. Buildings and office locations are connected together with optical copper wire, wireless connections that'll have different bandwidth speeds to data centers. Bandwidth is measured in bits, a 1 or a 0 per second, such as megabits per second, or millions of bits, or Gbps, or gigabits, or billions of bits per second. You pay for only what you need, but some providers offer other service options. A data center is a building where is also called a co-location or colo, where networks are connected together inside a data center. There are computer servers, also known as CPUs, which host websites, provide applications, perform backup storage, and other services. These services are contained in separate cages for security to keep one company's equipment separate from another. To connect one data center to another, there are routers which direct or route data packets called IPs, since we've discussed that before, data bits from one cloud or network to another, allowing you to send, email, pay bills, back up your data, and operate your data system. A data center may also be a cloud. Cloud computing means that all your computer service and business applications, from word processing, billing, order processing, managing your website, finding products, ordering a pizza, grocery, and more, can be all connected together via routers. There are thousands of clouds and millions of websites. Clouds are also connected together via routers, as one cloud does not host every website or application. There are many kinds of clouds out there designed for private, hybrid, or shared, or public. Companies often want private clouds for security, performance management, and other reasons. Connecting all these clouds together, or data centers with servers, data storage, or pics, videos, Instagram, etc., and streaming such as Netflix and iCloud is rather complicated. There are different kinds of computers used to make up internet together. We're going to go over this one more time: routers and switches. If you're in simple terms, if you're traveling and if you change planes on the same airline, travel or train or even package delivery, that's called switching. If you change to a different airline, that is called routing. Switching is easy, but routing can be very complicated and requires more management. Routing requires knowledge like of another airline network, or in this case, internet carrier provider. That is, you need to know if the other network goes where you want to go or publishes where they go, and what kind of services that other airline or cloud can provide in case you need to make a video call. Here's what the different technology fits in. Routers are expensive and complex to manage, but switches are not smart and just connect bandwidth pipes and connections together. If you have a network of 10 or 100 routers, that means a lot of expense and time to manage all of them, such as truck rolls, on-site visits to make changes. With switches, it's easier, but it requires more bandwidth to provide high performance. A new concept called SD-WAN, called software-defined area network, has emerged that is designed to eliminate much of the costs associated with routing. A cloud network would have fewer routers with switches used to provide the majority of data services, voice, video, streaming. One of the advantages of SD-WANs is called a control plane, a level of management for software-defined to look ahead like air traffic control to see the status of other switches to optimize flow and provide traffic management. One final point is that SD-WAN works with your own corporate network. However, when you cross-connect to another network, you need to connect them via routers. This is going to be mitigated by many different kind of service offerings by different kind of carriers and providers, so I would check with your actual provider to see what services you can use or can't use across different kinds of networks out there. Here's a few other final kind of points, even though I tried to make this thing simple and fast. If you're serious about SD-WAN software-defined networks, here are some of the technical benefits. Improved QoS, benefit from on-demand and dynamic traffic performance, provider new ways to manage platform API integration for carrier network operator integration, route management, enhanced component diagnostics and troubleshooting. I wrote another paper on SD-WANs and AI, and I think as you look at machine learning, machine intelligence as they're applied to these kinds of networks, you'll see many benefits, including disaster recovery, security, technology, and others. Last point here, a few other things out there is device management, migration to server, and network virtualization, accelerates BYOD, or bring your own device, provisioning, management first, and then provide scalable growth for customer applications. Cost, fewer boxes and lower layer interfaces, such as we're talking about layer 1, layer 2, and staff consolidation, reducing duplications and inefficiencies. Agility, on-demand network shaping, orchestration, and provisioning, improved traffic and capacity forecasting and physical plant geoforecasting, strategic design, test, and build new simulations and data visualization systems, and change algorithm models for evolving business demands. I'd like to thank you for your spending time with us today, and let us show you how good you really can be. This presentation is available at your site or on location, anywhere, anytime. Have a great day.